So, hi students, good evening, and welcome to this session on periodic properties. Okay, so we'll be discussing today about the periodic table in detail and also the periodic properties. Okay, so anyway, before going into this, let me give you a small introduction. So in ninth and 10th standard, you would have studied only some general properties. Okay, so how the periodic table, the new periodic table looks like. Okay, so what are groups, what are periods. Okay, but here in, so I would say what you have studied in ninth and 10th is just an introduction about the periodic table. Okay, so but now you will be studying all the exceptions, okay, and all the periodic properties in detail. Okay, so let's get started. So now, first before that, let me just tell you about the modern periodic table, because all the properties now about the periodic table depends on like the modern periodic table. Okay, so I think all of you would have seen about the the setup of the periodic table, like how many groups it has, how many periods it has. Okay, let me just tell you. So what is the modern periodic table? Modern periodic table. So you would have already studied about the history, like how it started. So just before this, you would have studied about the Mendeleev's periodic table, right? So now we will start. So the properties, everything starts from the modern periodic table. So what is this? This is completely based on modern periodic law. So what is this modern periodic law? All that physical and chemical properties of elements are periodic function of their atomic number. So all this while, whatever you have studied about the periodic table, that is just before this, what is that? Mendeleev's periodic table. Okay, so you would have studied the Daubeney theory, Newland law of octaves, all that is based on atomic mass. But the modern periodic table is based on the atomic number. Okay, so now all the properties, because it is based on the atomic number, all the properties, okay, of elements depends on valence electrons. Okay, so all the behavior or the properties, okay, everything depends on how many number of electrons are there in the valence shell, and it depends the properties, whether it is physical property or chemical property, all that depends on the valence electron. Okay, now let me just give you a small glimpse of that periodic table. See, it will basically look like this, something like this. Okay, so you have here, you have hydrogen and helium, then you have the first and second group here, and in between, let me just take it here, in between you have 3 to 12 groups. Okay, all this vertical ones, okay, are all called groups. Okay, and here you have 13 to 18 groups. Okay, so now let me just tell you, the vertical columns are called groups. Okay, all these are called groups. Okay, now the horizontal rows are called periods. Okay, so totally, okay, when it comes to groups, there are totally 18 groups. Okay, but when it comes to periods, there are 7 periods. Okay, so this way you have totally 7 of them. Okay, I hope this is clear. Now the first, second, now let me tell you more about the group. Okay, the first 2 groups, okay, that is first and second group, okay, they are called the S block elements. S block elements, because the last, that is a valence electron. So I think by now you would have known how to write the electronic configuration. Okay, so when you write the electronic configuration, the last electron will get into the S subshell. They are called the S block elements. Okay, then or they're also, and if you consider the P block elements also, so see here, this will be the S block, here it will be the P block. Okay, so both S and P, so that is from 13 to 18, they are called P block elements. And together both S and P block elements are also called representative or normal elements. Okay, so this is your S here and this is your P here. So in between from 3 to 12, you have the D block elements. Okay, so what do you mean by D block? The last electron will get into the D subshell. Okay, so now D block. So what is that here? You can see from the thing, like, from 3 to 12. Okay, so 3 to 12 are called D block elements, and they're also called transition elements. Okay, and if you notice again, there will be below this periodic table, you have another 2 rows like this. Okay, I'll just write it here, no space. So those two are called, okay, F block elements. F block, just below the periodic table, you have the two groups which are called F block elements, again because the last electron will get into the F subshell, and they are also called inner transition elements. Okay, I hope till here it is clear for you. Now coming to some of the properties. Okay, so now the first period, if you see, there are only 2 elements. I'll just tell you a little bit about the periods, the characteristic of periods. Okay, the first period, if you see here, this will be the first period. So that one will have, the first period is called the shortest period, which has only 2 elements. Okay, now when you go to the second and third, they're called the short periods. Okay, and it will have totally 8 elements each. So both the second and third, okay, you will have totally 8 elements. Now fourth and fifth, if you see, they are called the long periods, and they have 18 elements each. Okay, and when it comes to sixth and seventh period, okay, you have totally, this is the longest periods, I would say, longest periods, and they have 32 elements. Okay, so this is something about the periods. Okay, now you have, as I told you, below the periodic table, you have the 2 rows there. They are called the lanthanides and actinides. See here, as I showed you, I'll just give you a different color. See here, if you see, there will be 2 rows. Okay, the first one is called lanthanides, and second one is called the actinides. Okay, because the first element from lanthanides starts from lanthanum, okay, and from actinides it starts from actinium. Okay, so that's why it's called lanthanides and actinides. Now coming to this. So now if you want to study about the lanthanides and actinides, they have 14 elements. Okay, so that's it about a little bit about periods. Okay, now coming to the groups, some properties about the groups. Okay, so as I told you, there are totally 18 groups, and the inert gases, if you see towards extreme right, okay, you will have all the helium, neon, krypton. Okay, so the 18th group contains the inert gases. Okay, so okay, another little more about the groups. Okay, the first group okay, are called, they are the first and second group, I would say. They're all very active elements, okay. So I would say they are very reactive metals. The first group is called, they have the alkali metals, okay, and the second group will have, they are also called alkaline. All those elements are called alkaline earth metals. Both of them belong to the S block, okay. So the next 10 elements, if you see after the S block, okay, the next 10 are basically metals, but less reactive. I've already told you they all are called the D block elements or transition elements, okay. The last group, what is that? The last 6 groups, they have some speciality. They'll have metals, non-metals, and metalloids. Okay. So all this, I think all this little introduction you would have studied in 10th standard or 9th standard, okay, whatever. Now, let us see how you're going. So we know the general outline of the periodic table. Now we will see, suppose I give you an element, okay, how to find in which group it is present. So we have seen what is a group, okay, and I've told you depending on the groups, whether which block they are, S block, P block, or D block and F block, okay. Then you can also, as I told you, you can find in which group it is, which period it is, and which block it is. Okay, this is a very important question. So we will do that now. So next part is finding like how to find the, or how to identify in which group it is. Okay, so or group or period. Now let me tell you about the period. So identification, identifying the period, group and block of elements. So for this, you should know the electronic configuration, not how you write in 10th standard, like 2, 8, 8, no way. I think by now most of you would have learned how to write the electronic configuration as per Aufbau principle, 1s2, 2s2 and all that, okay. Only if you know that, you can understand this better. So in the period, how to identify, suppose I take, for example, let me take an element having 1s2, 2s2, 2p6, 3s1. Suppose this is the electronic configuration of some element. Okay, let me not tell you what the element is. Now, if this is the electronic configuration, how do I find which is the period? The last value, sorry, not the last, highest value here. Which is the highest value here? 3 is the highest value. So that is a shell, right? So that will be the period. So this element, so what is the atomic number? 4 plus 6, 10 plus 1. So 11. Atomic number is 11. So that this is the electronic configuration. So this element, so what is that element? You all know 11 is sodium. Okay. So this belongs to period 3. So you can just go and see whether it is coming under the third period. Okay. So this is period 3. Okay. Suppose just roughly if they give you, okay, find where does, iron, we know we have used iron left and right. Okay. Everywhere in everyday life, we use little bit of iron. Okay. Right. So now let us see to which block, which period it belongs to. So iron, first you have to write the electronic configuration. The atomic number is 26. So let me write the electronic configuration. If you don't know, please remember 1s, 2s, 2p, 3s, 3p. In case you have not learned, okay, 4s, 4p, 4d, 4f, the electrons will get filled like this: 1s2, 2s2, 2p6, 3s2. This way it will go. Okay, so S will have a maximum of 2 electrons, P will have a maximum of 6 electrons, D can accommodate 10 electrons, F can accommodate 14 electrons. Okay, so now as per that, so this is called your Aufbau rule. So let me write the electronic configuration. Okay, so this is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. See, I've written completely, and you can see where iron belongs to in the periodic table also, okay? So that will be a transition element. It will be exactly in the D block. Okay. Now, how do I find the period for this? So which is the highest value here? Highest value is 4 here. Okay. So the period number is 4. Okay. So don't see that, how the electron is getting filled. Okay. See that value. This is called the n value. Okay. So that should be the highest. So that period it belongs to. Okay. So here in this electronic configuration, 4 is the highest value and it belongs to the 4th period. Okay. So now we know about period. It's very easy now. Okay. Now let us see block. Now I'll just give you the same example. See in the first example where we spoke about sodium. Okay. Now the last electron, where does it enter? It enters the third period, third shell, and the electron enters the S subshell. So this is the S subshell. So depending on that, you can say that it belongs to S block. So a sodium belongs to S block. Okay. Similarly, in the iron, okay, so when I write the electronic configuration, the last electron, it enters the D block. Okay. See here. So this belongs to D block. I hope it is clear how. So block and period is very easy. Okay. So now suppose I'll give you another example. Okay. 1s2, 2s2, 2p6, 3s2, 3p3. Okay. A general. What is that? 10, 11, 12, 13, 14, 15. Okay. So now if I see this electronic configuration, you can say which is the highest value? Highest value is 3 here. So it belongs to the period 3. And the last electrons enters which subshell? P subshell. So the block is P block. Okay. So I hope it is clear for you now. So now coming to the next one. So like that, you can try many more. Okay, let me just, so I've already done iron also. Okay, so it belongs to period 4 and D block. Okay, now, so next one, what we are going to study is the group. Okay, so here it is little tedious. Let's see slowly. It's very nice to identify, right? Okay, so now let us see how to find out the group. Suppose it is S block. Okay, S block elements. So let us see one by one. S block. Okay. So we have seen sodium. Okay. Sodium 1s2, 2s2, 2p6, 3s2, sorry, 3s1, right? 10, 11. Now, when the last electron, okay, enters here, it is, so what is the period now? We have already seen the period is 3. The block is S block. Now, you have to see the number of electrons in that S subshell. Okay, so here S has 1 electron. So if it belongs, if that is 1, then please just write the group number is 1. It belongs to the first group. Okay, I hope it is clear. Suppose I take, okay, another thing, imagine, let me write another electronic configuration. 1s2, 2s2, sodium, magnesium, okay, 1s2, 2s2, 2p6, 3s2. Magnesium is 12, right? So this is for magnesium. So again, you can see the period, the highest value is 3 here. Block is S block. S block, and the group is, so you can see only 1 and 2. If S has only maximum 2 electrons, so depending on that, you can say first group or second group. So now you can see here there are 2 electrons. So the group number is 2. It belongs to the second group. Okay, I hope this is easy. Now coming to the second one, second part. Okay, so if it belongs to the P block, how to find the group number? Okay, so I've gone extreme right now. So let us take some examples. Let me take atomic number 19. So how do I write 19? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, right? 2, 4, 10, 11, 12, 18, 19. Yeah. Okay. So here, anyway, this doesn't belong to the P block. We know the period is 4, block is S, and group is 1. Okay, because you have 1 electron. The same thing, let me just write another element. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. See here, I've written this. So what is the atomic number? 4, 10, 20, 35. Atomic number is 35. Okay. So now you can see this is P block, right? So now let me first write the period number, which is 4. Block is P. And you have 5 electrons. So how do I find that? Okay. So this will be always the period number will be equal to 12 plus whatever electron you are seeing here in the P subshell. So here it is 5. So it belongs to the 17th group. Okay, I hope this is clear. So before that you have 12, right? So in the till the D block, right? So you have 12 plus the number of valence electron will give you the block number. Okay, so this is also very easy. Suppose, let me do a simple one. Let us take fluorine. Okay, 9, the atomic number is 9. So 1s2, 2s2, 2p5, right? So 9 electrons. So now what is the group number? Let me first write the period is 2, block is P block, and the group is, so how many valence electron again here? 5. So you will have the group number will be 12 plus 5, which is equal to the 17th group. So you can go and check whether fluorine is in the 17th group. Okay, I hope this is clear. Now coming to the D block elements. Okay, D block, the third one is D block, not right, D block. How to find in D block, how to find the group. Okay, so here we will write the group number is equal to 2 plus number of electrons in n minus 1 D subshell. Okay, so now let us see for some examples. Okay, let me write atomic number 43. Okay, it's a very, very big one. So you can try this also. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d5. So you can see just by seeing the last electron enters the D subshell. Okay, it belongs to the D block. Okay. So now which is the highest value here? Period is what? The N value should be the highest. Okay, so this will be the highest. So period is 5. Okay, now the block, as I told you, the last electron enters the D subshell. So this is D block. Now coming to the group, I've already given you the formula. 2 plus number of electrons in n minus 1 D subshell. Okay, see here, this is your n. Okay, just before that, this one 4 and this 4, this will be your n minus 1 shell. Okay, the highest value will be the n. So now n minus 1 D subshell. So how many electrons are there? 5 electrons are there. So you will write 2 plus 5. So this will be in the 7th group. Okay, so you can try, play around, it's fun, okay, to do all this. Now let us do one more example. one small example. Suppose I say 23, atomic number 23. So immediately first write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. So we are writing the electronic configuration as per Aufbau principle. Okay. So now let me just quickly do the period is, which is the highest value. Let me just give you different colors. This one. So your period is equal to 4. Okay. Now let me go to the next color. S. So block is, sorry, not this. Sorry. This is, S will be the last electron. Let me show you in a different color. This one, the D subshell. So block will be D block. And coming to the next one, okay. So this electrons, now you have to take into consideration for determining the group. So group is 2 plus 3, which will be equal to fifth group. So this element, atomic number 23, belongs to the fourth period, D block, and the group is 5. Okay, I hope this is very clear. So we have finished S block, P block, D block. Now let's see the F block. Okay, F block is very easy. The fourth one is your F block. If you see closely, take out the periodic table and check. Okay. So if you see, there are two rows exactly below the periodic table, and all the F block elements, remember, they all belong to one group, that which I will tell you. Okay. They all belong to third group. Remember, both actinides, write down that both actinides, sorry, first let me write lanthanides and actinides. Actinides, both of them belong to group 3. Okay. Now, what is this element? So what you have to remember is, please remember, lanthanides, the atomic number will be from 57 to 71. From 57 to 71, all the elements, they belong to lanthanides. As I told you, they all belong to group 3. Similarly, actinides belong to, they have the atomic number starting from 89 to 103. Okay. One thing is, lanthanides belongs to the sixth period. Okay. And actinides will belong to the seventh period. So anytime you see the atomic number between 57 to 71, just say that this belongs to sixth group and group number 3. If you see the element atomic number, because you can't keep writing such a big, 103, you can't sit and write in a competitive exam all the electronic configuration, right? So half the time will be going in that itself. So if you see between 89 to 103, just say it belongs to seventh group, seventh period, and group number is 3. Okay. So, and as I told you, both, again, if you see 57 to 71 and 89 to 103, both of them belong to F block. So this is how you have to remember. So F block is very easy. Just remember, you have to remember. You can see, you can try writing the electronic configuration, everything. So all this. So just blindly remember this value. That's more than enough. Okay. So now, till now, we have identified. Okay. So which period, which block, everything. Now let me give you some small questions. I hope you would have studied, like when you were studying the previous chapter, atomic structure, when we write the electronic configuration, we have seen some exceptions, right? So I think you all know about it. Both copper and chromium have some exceptions. Let me just see some questions. Are they? Oh, okay, fine. Okay, so now, so let me give you some practice questions. Suppose I give you atomic number. Let us see the exceptions. All this you will not study. Like, as I told you, 9th and 10th, not only this chapter, every chapter, like, what you study in 9th and 10th is just the introduction. So you have so much amount to be studied in 11th and 12th. I'm not scaring you. You learn with some fun, you will enjoy it. Okay. So now, exception, as I told you, we have studied in atomic, when we write the electronic configuration for both chromium and copper. Okay. Chromium atomic number is 24 and 29. When we write, it is an exception. Okay. So what is that exception? Let me write for chromium first. Chromium atomic number 24. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. This is how you write. Okay. You will write. But actually, how do you write? You would have studied in atomic structure. There's an exception. So the correct electronic configuration, how you write would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Okay, this is one major exception. Here, these two will change. This will become 1 and this will become 5. See here. Why is that so? That is because any shell which is half filled or fully filled, half filled or fully filled, okay, they will give extra stability. Okay, so D electron, if you see the D subshell, D has maximum 10 electrons, so half of them is 5. So in case it has to jump one step ahead to have some stability, obviously it will do it, right? Imagine if you have to put little more effort, okay, then you can clear your competitive exam. Obviously you'll put that extra effort. Same way, even the elements are like that, okay? So it has to put little effort to bring this one electron to this here, so that it will give you extra stability. Okay, so this happens in chromium. Now, so this is your correct electronic configuration. But the exception, this is your correct, let me write, correct electronic configuration. But when you write the period or group, okay, or block, please follow the original one. Please follow this when you are writing the period, because as per the second one, you cannot write, it will not give you the correct group at least. Okay, forget, it will give you the correct block, it will give you the correct this thing, what is that, period, but it will not give you the correct group, only that. Okay, so now see here, if you want to write as per the correct electronic configuration, you will write period, block and group here. So period is, which is the highest value, 4. The last electron enters the D subshell, so D block. Group will be for D block, how do you write? 2 plus the number of electrons, so 2 plus 5, it has to belong to 3D, sorry, 7th group. But this alone is wrong, okay? This is right, this is right, this alone is wrong. So I will write as per this electronic configuration, okay? So that will be 2 plus 4, which is equal to 6 group. So this will be your correct answer. So what you're going to study in 11th, not only in 11th, even 12th, like as I told you, it's just extrapolation of 9th and 10th, right? So everywhere you'll be studying everything in detail, okay? So here, so please make this correction. This is what they will ask you in competitive exam. They are not going to ask you the general trends, okay? All these small things they will ask you, fine? Now, coming to the next one, copper. Let me just quickly finish the copper one also. Another exception, copper. The atomic number is 29. So we will write the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. This is how we usually write, but this is not the way we write. The correct way of writing electronic configuration, many of you would have studied, okay? So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, because if the last one is fully filled, I just wrote, right? Fully filled and half filled will give more stability. So this electron will jump here, so it will become 4s1, 3d10. Now, let me write the period. So as per both, the highest number is 4. So period is 4 and the block is D block elements. Coming to the group, you can all try and see whether the answer is right. Okay. So which one will you take? Okay. The actual way how you write this one only for group. Okay. Because you will not use this one. So now as per this, we will write the group number as 2 plus 9, which is equal to 11, which is the correct group number. So these are the exceptions. Okay. So now I hope you all got it. So now coming to the next. Okay, let us do just 2 more questions based on this. Let's see some practice questions. Okay, you can try. I need not tell you, so you people can try. Okay, suppose I give you the electronic configuration because you know already. I will not tell you how to write all this. Xenon 4F7 3D1 6S2. Okay, also remember, see some things which you have to remember, I'll tell you. Okay, whenever I take the class, I'll tell you this, you better remember so that it will be useful. So the atomic numbers of all the noble gases you should know. And what are they? Helium, neon, argon, krypton, xenon. Okay, I think if you would have studied the atomic structure properly, you will remember this. What is the atomic number? 2, 10, 18, 36, 54. Right now you see a quick way how to find the block and all that. Okay, xenon is what? See here, 54. So this is 54 plus 54 electrons plus how many are there? 7 plus 1 plus 2. So totally 10. This will be 64. So what did I tell you? Okay, see, within 1 minute, not even 1 minute, few seconds, you can answer this question. Okay, so if they ask you which group it is, when you see 64, you know that 57 to 71 belongs to F block. Right? A super trick this is. So that means immediately you can say this is 64. So this belongs to F block. Okay, obviously you can see from the electronic configuration, the valence electronic configuration, the highest n value is 6. So the what is that, like your period is 6. Okay, and your block will be F block. And what did I tell you about the group? I told you all the lanthanides and actinides, and also remember the atomic number, everything, all those belongs to third group. So easy, you found the block, you found the period and all that. So you can try many like this. Okay, you can just pick up, try all this. It will be fun doing it. Okay. So usually they ask this kind of advanced question so that you can do it in no time. Fine. So we have just seen how to find. Now let us go to the next one. They are called the periodic properties. Okay, now let me just quickly tell you. In 9th or in 10th standard, I think, in the carbon chapter, or no, periodic table you have, you will be generally studying the general trend. Okay, see, with respect to atomic radius, you will see about some electron gain enthalpy, okay, or ionization energy. You would have seen only the general trend. Okay, so now obviously you're going to a higher class. Now you will be studying all the exceptions, okay, in those physical properties, periodic properties. Okay, now let me explain all that now. So I think today we'll be doing only one property in detail. So apart from what is there in the CBSE textbook, we will be teaching you more because you're going to attempt for competitive exam. Okay, so now, so what are the general properties which we study here? The periodic properties. Okay, first one, we will study about the atomic radius. I think you would have already studied. As I told you, you would have studied only the general trend. Okay, then you have the ionization energy. So what is ionization energy? Energy required to remove an electron. Okay, now third one, I have a question. No, only these two exceptions. Syed, only these two exceptions. Okay. So you in this chemistry is like, you will be studying more of exceptions than actual rules. Okay. So wherever exceptions are there, only there I'll tell you. So I'm just telling you some properties so that you can remember. Okay. Not everything, not all elements will follow this. Okay. Only copper and chromium, because like compared to the other elements, if you go for higher elements, okay, Syed, what will happen? The size is bigger, electronic configuration is bigger, so even this jumping is little difficult, okay, to gain that extra stability, because these atoms are slightly smaller compared to the higher bigger elements. These can undergo that stability. Okay, so remember that. So whenever we tell exceptions, just remember that only that is important. Okay, concentrate on that. Okay, fine. Ionization energy, then we will be studying about the electron gain enthalpy. So energy required to add an electron, okay. And the fourth one, we will be studying about the electronegativity, TEVT. All this in detail. But today, I don't think we can finish because this needs another 3 classes, right? So today, let me just tell you about the atomic radius. Atomic radius. So what is that you studied in 10th standard? Okay, so I'll just tell you, across the period, that is from left to right, and down the group, that is top to bottom. Okay, what will happen to the atomic radius? You would have studied that the general trend was what you have studied. Okay, the atomic radius or size decreases. So let me write AR, atomic radius decreases. And what is this trend? From top to bottom, it increases. So write down top to bottom, it increases. Why does it increase? Because the number of shells are being added. Okay, so the size will increase. This is what you have studied, just general. But no, that is not enough. Okay, so now we will be studying all the exceptions. Basically, the exceptions is what we are going to study in detail. Okay, so now in the atomic structure chapter, okay, you would have studied the electron behaves like a wave. Okay, again, let me tell you, when you studied your 10th standard, okay, you would have studied that atom has a nucleus and the shells are like this. Okay, how do you calculate the radius? You will say the midpoint of this and to the last shell, this one I will take as a radius, right? But what will actually happen is, like, you would have studied more in, as I told you, again I'm repeating, in atomic structure, you would have studied the electrons are wave particles. They'll behave as wave. It is not a fixed thing. Okay, they're not fixed orbits. Though they are fixed orbits, the electrons will move. Okay, they're all wave. So if you see, if an electron is moving, it is not like this, it's a wave function like this. Okay, now can you exactly find the correct radius of this? Then your calculation will become wrong when it's a wave, because you can't say which point I'm going to take. Imagine between this and this, it will be smaller. Between this and this, let me tell you here. Okay, it will be a little bigger. So we will not account that. That's only the general thing what you're studying. But here we will divide first the radius. Okay, all different types of radius. Depending on that, we will tell you the trend. Okay, now let me tell you what are the different radius. What I think all this you would have studied, the different types of bonds. Okay, so all the next one we will be studying. So here we will not talk about a particular atom. We will study the radius with respect to a molecule. Okay, that is atom in the bonded state. Bonded state, or when it is interacting with something, an interaction state. Okay, when it is a bonded state, we will have to study about the different bonds. Okay, what are the different bonds? One is your covalent bond. How is a covalent bond formed? By sharing of electrons. Covalent bond is formed by sharing of electrons. Now second one is your metallic bond. So here we will be studying about the covalent radius. Now coming to metallic bond, this will be like, you will be studying about like, metals, like you have the electrons surrounding it. So here you have the metallic radius. I'll tell you everything in detail. Then you will study a very important one, which is called van der Waals radius. So most of the gaseous molecules, okay, we will consider the van der Waals radius. Van der Waals is the weakest force, weakest bond, and we don't call it as a bond. Actually, we call it as the force of attraction, because so weak that we can't call it as a bond. Okay, so now the last one, what we are going to study is the ionic radius. Okay, first let us see about the covalent radius. So as I told you, how do you find, okay, imagine, see here how much you will study in detail covalent radius. As I told you, it is formed by sharing of electrons. So how do you denote that? Again, you will write like this, sharing of electrons. Okay, now this is atom, let me call it as some X, and this is an atom X. Okay, similar atoms, between similar atoms it has formed a covalent bond. Okay, like hydrogen, for example, is hydrogen. Okay, now for such thing you will say this radius. Okay, how do I calculate? This will be your distance between one nucleus and the other nucleus. So this is called your dx, the distance between the two atoms. We also will talk about this, is also called the bond length. Okay, so that we will study in detail later. So dx, so how do I find the r of covalent bond? The radius of covalent bond here will be equal to dxx by 2. So this will how I find the radius. First, let us see how to calculate the radius. Then we will see the trend. Okay. Now, I have taken a covalent bond formed between two similar atoms. Now, if I say, imagine HCl, if I take, you have two not the same atoms, right? Hydrogen and Cl, or methane, anything. Example, the second condition, this is your first, second, where you have atoms like X and Y. Okay, so here when you have two different atoms like X and Y, we will check condition 1 is the electronegativity. If electronegativity is same, this is your condition 1. Okay, that is both X and Y, if they have almost the same electronegativity, then you have a different value. So let me write it like this: X, then you have Y. Okay, you have atoms like this. So this is your dxy. So here I will call dxy. Now this, the radius will be equal to radius of X plus radius of B. This is how I find the radius. Okay, so this example is methane. Fine. Now coming to the condition 2. Yes, you can ask them. Yeah, I'll just ask. I'll give you. Suppose we have, when the electronegativity is, if one is higher than the other one, okay, some difference is there. Imagine if X is greater than Y. Okay, so here we will have the bond length. So here it will be dxy will be equal to, you see here, Rx plus Ry minus 0.1, okay, chi of X minus chi of Y. What is this? This is electronegativity of X, and this is electronegativity of Y. So this is your formula. They can ask you such questions. Here, let me tell you, in competitive exams, they can give you the value, okay, of the electronegativity of both the atoms, that is X and Y. They can give you the radius of one, either X or Y, and they will ask you to find the bond length. These are all nothing but your bond lengths, okay. So now they can ask you. So all these are very important. Again, I will tell you, these are not there even in your NCERT, okay. So we will be teaching you much more than that. Now, the last, okay, sorry, these two are the two conditions. Now coming to the covalent radius. Gokul, we'll finish little bit and then I'll ask some questions to them. The second type, let me tell you about the van der Waals radius. Van der Waals radius. As I told you, beginning itself, this is the weakest force of attraction. We will not call it as a bond. So it's basically no bond. It's just a force of attraction which is holding them together. Okay. So now, so here that force is called that is the intermolecular force. Intermolecular force is also called the van der Waals bond. Okay. Now, where like this is basically found in some gases, okay, and between molecules. Okay, imagine I'm going to take H2 gas and a H2 gas. These two are molecules. Now, between these two molecules, you can't find, because both are non-polar, okay, the bond, okay, or what will, it will have some, obviously the molecules will come closer together. So that bond, okay, or that force of attraction is called your van der Waals force of attraction, okay. So here, how do I find the value? The radius of van der Waals force is equal to d of H2, okay, H2, H2. Okay, the two molecules of H2 divided by 2. This is your formula. Okay, and basically for noble gases, okay, this is applied. Application is basically for noble gases. If you want to find out the radius, so always remember noble gases will have the longest radius. Okay, so if I say helium and helium here, okay, this is called your van der Waals force of attraction. So how do I find the radius? So this is your d He, He. Okay, so the radius will be of helium will be equal to d of He, helium divided by 2. Okay, so now coming to the last one. Okay, that is your metallic radius. Third one is your metallic radius. Okay, so what is metallic radius? Let us take iron or copper. Okay, so for that, how are they, like, you can see if I take a copper wire, it will have copper atoms like this. Okay, in 3 dimension like this, it will have all the copper atoms. Fine. So this bond between these atoms in a metallic thing is called the metallic bond. Okay. So how are they coming closer to each other? It is because, see here, each one will have the nucleus. Okay. Now you have the electrons revolving here. Okay. So these, imagine for this particular atom, okay, this electron will be attracted by this nucleus. Okay. Then obviously above that there will be one, this will be attracted towards this. So by that force of attraction between the valence electron of one atom and the nucleus of the other atom, so they'll form a bond that is called the metallic bond, because metals, they have the free electrons around them. Now coming to the how to calculate the radius. So if I want to calculate the d or the radius of metallic metals, it will be equal to dmm, that's a diameter between these two, divided by 2. So this is how. Yeah. Now I have a question. Can you tell me, so we have studied, okay, the metallic radius, the van der Waals radius, and the covalent radius. Can anyone tell me which radius will be highest among this? Yes, can you all think about it? Which radius will be the biggest and which will be the smallest? Can you all try? Metallic radius is basically like this. Yeah. Can anyone answer? Yes, very good. Shagun, correct. And which will be the smallest radius? Yeah, at least one is enough. Which will be the longest? The radius will be bigger for molecules which has van der Waals. Very good. Not metallic, van der Waals. Okay, see here. So, what did I tell you? Covalent is smaller like this. Van der Waals is between the molecules like this. This and this point, this is your van der Waals radius. This and this divided by 2 is your covalent radius. And this is your metallic radius. See, I've just given you easier way. Metallic. Yes, Ankit Das is right. Fine. So you can see here, from this you can say that van der Waals radius is bigger than, next will come your metallic radius, then comes your covalent radius. This is your, see, I'll give you a competitive question based on this also. Okay. So now let me just tell you some exceptions. Okay, clear? Okay, fine. So now I have, so next one, so we have seen how the radius varies, okay? So we have different, so depending on what molecule and what is forming, you have to go for the radius as per this, okay? Now, coming to the next topic, okay, variation. So we have seen, till now we have seen only about the radius, okay, atomic radius, okay. Now based on this, again you have to apply this along a period and group, okay. So now let us see the variation. As I told you, you all have studied that along the period, that is left to right, okay, the atomic radius decreases, right? And across the group, that is top to bottom, the size, the radius or the size increases. This is what you have studied in 10th standard. Okay. So now let us see how we'll see all the exceptions now. Okay. So now see here, when I take, let me talk about period alone. I might take another 10 minutes. Okay. Period. So let me take a period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay. So all this. So these are all second group elements. Sorry, second period elements. Okay. So now what is the atomic number? 3, 4, 5, 6, 7, 8, 9, and 10. These are the atomic numbers. Okay. So you have the electronic configuration 2, 1. Let me write as per your this thing 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. Okay. We know that this also is your Z value, right? Z value is number of protons. Okay. So your Z, okay, is also equal to your nuclear charge. We also call it as nuclear charge. What is that nuclear charge? Okay, the charge on the nucleus, right? So suppose let me consider this one, 3. It will have, okay, 3 protons in the nucleus, okay, and you have the the electrons here. So the electrons will be attracted by the nucleus here. Let me write this as the nucleus. But when let me consider the 6th one here, you have 6 protons which is attracting the electrons here. Now let me go to the 10th one. You have 10 protons attracting the electrons, right? Now you can see see, what is this electroeffective nuclear charge? That's what we call it as, right? You would have studied in 10. As the atomic number increases along a period, more protons are pulling those electrons, okay? So more attraction. So just slight, it is pulling more, so the size decreases. That's why it's called effective nuclear charge. You all would have studied, okay? This is what is the explanation, okay? So you would have studied that from left to right, number of protons increases. Okay, that is what does it mean? The nuclear charge Z increases, and the electron attraction also increases. And that is why your size or atomic radius, let me write it as atomic radius, decreases. This is your conclusion from this. Okay, now I'll just give you one example. Okay, one small example I'll give you. Between hydrogen and helium, can anyone tell me which one will have more radius? Hydrogen and helium, can you all try which one will have more radius? Try, all of you. Give me the answer quick. These two belong to the first period. Yeah, nobody has given me the right answer. What did I tell you? Noble gases. This application is for noble gases. Okay. So when this is a noble gas, and all noble gas will have what kind of a bond? This is your van der Waals bond. But hydrogen, we saw, it is your covalent between two hydrogen, it is your covalent bond. Now tell me which one is your, which, see, this is an exception. This is how you have to study. These are all your competitive exam questions, okay? These are all basically exceptions. The trend, what you've studied is in 10th standard. Now, these are all the exceptions, okay? You've studied about the radius. You have to apply that radius to here, okay? What type of radius is formed, okay? Now, between this, I know, because along the period, the size decreases, but noble gases will have van der Waals bond, and van der Waals bond will have a higher radius. So for your disappointment, helium will have more radius than hydrogen. The reason is helium will have van der Waals bond and hydrogen. Okay, now one last question. Try this. I think I'll be happy if you all can answer. I am taking the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay. Now tell me, I just want which one will have the highest radius. Highest radius. That is the first highest radius and the second highest radius. Give me both. Give me both. The highest, the first one, after that, which one will follow? They can give you like this. They can give you 4 options. Lithium, beryllium, boron, one is less greater than, you go and see your competitive exam. This is how they'll give you. Just let me know. See, try, all of you. The first highest radius, the second highest radius. All this belongs to these elements belongs to the second group. Sorry, second period. We have still not started the group. Akshat, very good. Bharat, correct. Swarna Manjari, check. Small mistake you made. Yahya Anand, I think it is any. Okay. Neon, very good. Bhanu Prakash got it right. Oh, okay, fine. I'll just explain. Most of you have got it right now. I'm so happy. Okay. So, which is a noble gas here? Okay, I've already told you. So, along the period, the size will decrease, but this fellow happens to be the van der Waals, will have a van der Waals because it is a noble gas, right? The last element, the last group, 18 group, all are noble gases. Okay. So, the first place which will have the highest radius will be neon, followed by, you have to start from this, right? Lithium, then beryllium, then boron, carbon, nitrogen, fluorine. Okay, only the neon you have to push it in the first. So neon will be first, followed by lithium, then beryllium, until fluorine you can write. That's all. That's why we study about the radius. Okay, so these are all competitive exam questions. Okay, and so like this we will be studying all the exceptions, and every time we will give you some practice questions. I'll give you some problems to work out here. I will do some and you'll have to do. Okay, so we'll have to, please remember, you have to enjoy and study. Otherwise chemistry is, sometimes many people think it is dry. Okay, enjoy, then you'll have fun learning it. Okay, so I hope it's clear for all of you. So like this, we will be studying about groups. Okay, in groups, what are the exceptions? Then coming to electronegativity property, electron gain enthalpy, everything will be studying in detail in 11th standard. Okay, I hope that's enough for today. Any doubts still here? Mentors, can you please let me know if they have any doubts still here? Okay, fine. So can we wind up? Yeah. So please give your feedback about today's class. Okay, don't forget. Thank you all once again.